Hello guys, this is Expert Funda and we're watching on YouTube. So let's see the today questions that we have given. So today question we have given is 2 to 6, okay, and this is an invert binary tree. So the given root is a binary tree we have given, and we have to invert the tree and we have to return its root. Okay, so let's understand the example first, right? So in example first, what you can see that we have given this a first tree, right? So first tree root is 4, right? And similarly its root is also 4 after the inverting. But if you see the children, right, 2 is this side, you can say left side, so it is going to the right side, right? And if you talk about the 7 is going to the right side. Next, this is the first level, right? Now for the root 2, right? For now root 2, there is two children, 1 and 3. So when we go to the root 2, right, when we go to the root 2 here, so its children, the left will go to right and right will go to the left, right? So right is coming to left 3 and left is going to right. Similarly for the similarly for the subtree of root 7, you can say that is coming interchanging 6 and 9. So 9 is coming into the left, that has position early in the right, and similarly for this one, right? So you can see always what you have to focus. If there is binary tree, means two things we have, right? Two left and right node, right? So if this is root, right, and this is 1 and 2, let's suppose, so what the binary after the invert of this binary tree, it should be root should be at this position, right? But this is left and this is right? So the left should go to the right, and so that we can say right will come to left, right? So we have to put like this, and this will go to this side. If there is a kid, any kid is there, like any sub, if this is a subtree, right? If any subtree is there, like there is a 3 and 7 is there, suppose, just example. So what you can do, this one we have already placed into the right side, right? As a right after the invert. So now we have to exchange these two value, right? Two nodes, you can say. So the 7 will come in the right side, and 3 will go to 3 will go to right side and 7 go to left side. Okay, I think you have understood. So in this way we have to return the output, right? So the root is given, and we have to return the inverse of its root. Okay, similarly you can see here example 2 we have given, in which 2 is on the root and this is also root 2, right? So 1 will go to the right side and 3 will go to this side, as I told you about this one. Okay, similarly if we have root is empty, right, after the invert it will be empty, right? If there is no node, then means after the invert there will be no node. Constant we have given is the number of nodes in the tree is in the range 0 to 100, and node value is between minus 100 to 100. So this question is very important, has been asked many times in Google, Facebook, Microsoft, many other top companies, right? Like in the FANG, this question has been asked. Okay, so I will recommend you should uh, go through all the approaches that we will discuss today. So today the first approach we have is recursive approach, right, in which we will see how we will do the implementation. Okay, so in the first part of this video you can see we'll see the recursion, and then we will see the iterative approach. Okay, so first we have recursive approach, this. So you can see here what we have tree is given 4 2 7 1 2 6. So if we will do the invert, right, so this part, this subtree will go to the previously it was in left side, now this will go to the right side, right? And similarly its children, right? So first if we will do the recursion on this root, right? So we will do on this left and right child, right? Left and right child. Similarly if we'll consider this one, we have to do with this 1 and 3, right? If the same recursion we have to same rules we have to apply on this one. So we have to apply on its children, right? Means complete this, we have to understand that this left subtree is a complete independent subtree. And so if you will see that the 1 is in the left side and 3 in the right side, so after the invert, 3 is coming to the right side and it is going to the it is going to the left side and it is going to the right side, right? So previously it was in the right side now, and this is in the left side, right? So independent root should also be moved like the previous one that we used to do, left and right, right? If this is in the left, it will go to the right side. So what we will do, first we will inverse the empty tree, right? The inverse of the empty tree is always an empty tree, right? That we have seen the last one, right? This one. Okay, so we have to apply this algorithm. Next, what we will do, the inverse of the tree with the root r, right? And subtree right and left will take, right? So this is the subtree, this is left, and this is right subtree. Okay, this part is right subtree. Okay, so with the root r, you can say whose right subtree is the left. We have to do the inverse, right? So whose right subtree is the inverse of the left and whose left subtree is the inverse of the right, that we can see in this picture, that we will do like this only. Okay, now if we'll talk about, if there is only one you can say uh, uh, children is there, right? So right subtree have 7 and 7 have 7 is a root and there is only one, this one, and there is nothing, you can say null is there, right? So what we will do, we will exchange this null with this one, right? We can say, so this will come now this side. Previously it was in the you can say left side, now it is in the right side. Okay, so we have to apply this algorithm. Now the recursive is very easy, right? So what we will do, first we will check if the base case, and if the base case root is not null, not null, right? If root is not null, means there is a root, right? And it has some children, the left and the right children. Okay, so this root, if this is a root, right? So if this is a left children and this is a right children, right? So if root is not null, means we will go into left and right. Either this, there will be a value, either there will be value or there is null, right? So what we will do, we will pass root dot left and root dot right. So think, if this is a value and this is a null, let's suppose. So what will happen, we will invert, we will call the invert again. So this invert, this rule will apply again. Okay, so this time for this left one, what will happen when we come to here, so this is root of left, you can say, right? Not null, so we will apply this for this loop again, and its children will get added into again, right, in this one. So next time what we will do, here the invert tree we are passing, right, root dot left, and then we will pass L1 or R1, you can say, like this, that we are doing here. But here is null, right? What happened, this will not go inside, right? From here it will not go inside because this is not null. So we will break the condition to go iteration, you can say recursion will not go happen here. But let's consider the initial position, that we have root, left and right, three things. So first we will do the recursion for the same, for the left one, for the left subtree, and similarly we will do for the right subtree, right? We will do this pattern. Now we have to swap this one and this one, this one and this one we have to swap, so that we will take a temp, right? And in the temp we will pass, we will store the right one. So this will go into temp, right? And on the right side we will add root dot left, right? On the right side we will update root dot left. Next time what we will do, root dot left equal to, we will pass the temp, like we used to swap the value, right? There is if there is a equal to 10, b equal to 20, we used to take temp t, and we will store a value, right? And on the b we used to pass a, right? And sorry, uh, mm, on a we used to pass b, and on the b we used to pass t, like this, right? We used to do similarly. In this way we will do the swapping, and once this is swept, so this, now this will go here and this will go here, correct? This will happen, and then we will finally return root, right? So in this way what will happen, all the subtree it will get worked. It will invert all its subtree, right? So first, if we'll talk about the root one, right? So first time what will happen? It will go through the left. So it will go to left and its right. There is some value L1 and R1 you can say. So what will happen? Second time what will happen? We will pass this one. So it will go to these children also. So like this, it will go to its all its children you can say, right? It will reverse. First time it will take the this parent. It will go to there. Now it will go to this part. Now it will go to this part. Like that, it will become okay. It will go in the recursive way and it will update its all the values recursive. Now if we'll talk about the complexity, right? The complexity, because see we are going through all the nodes, right? If the n is the number of nodes you can say, so what will happen? We are going with all the nodes, right? First we are going for the root, right? So next we are going to left, another we are going right. There is, if there is a children, right? So we are going all the nodes, we are doing the recursion, right? Here you can see we are calling each time we are passing root, now left and right. So if there is only three nodes, let's suppose 1 2 and 3, we will pass 1 here, 2 here, 3 here, correct? Means total O of n uh, time complexity will be there, right? And for the space complexity we are we will have the same O of n you can say as a space complexity. Now another approach we will see, right? So what we will do, we will use the breadth first search like approach in this approach, right? So we can crack the problem iteratively in a manner like to breadth first search you can say. So first of all what we will do, we'll do the swap the left and right child of the all the nodes in the tree. We will swap, right? That we have seen already. Then we will create you can say a queue to store nodes whose left and right child have not been swapped yet. And third will initially what we'll do, only the root is in the queue, and as along the queue is not empty, we will remove the next node from the queue and we will swap its children and we'll add the children to the queue. And then we'll do null, we'll check null nodes are not added to the queue, and then queue will be empty and all the children will get swapped and we will return the original root, right? If you not understand, you can see this thing, right? So what we will do, we'll take the iterative approach, right? So in this iterative approach, let's suppose we have 4, then we have 2, then we have 1 3 7 and 6. So this is our left and this is our right, okay? Sorry, okay. Now let's suppose we have gone through first this one, now we are going to, we are at here, okay? So at here what we have 7 here and 2 is here, right? So node we are at this position, we are getting 7 and 2. So bit for search will go with its you can say all along you can say we will go, right? So what we will do, we will swap this one, this will go to here, right? And this will go to here, this position, right? On this both position we will update, we will swap this one. So after the swap what will happen, 2 will come here and 7 will go here, got it? As you can see, now we have taken one queue here, right? And what we will do, on the queue, we will add first, we will go through the root first, right? So we will add the root here 4, and then we will move to first we will remove from there on the on the queue, we will remove, we'll do poll. And 4 have 2 children, right? 7 and 4 you can say there is a what we have, there is 2 we have and 7 we have, correct? Correct. So what we will do, we'll do this swap, right? And once this swap is done, then what will happen, uh, two things we have here, right? 4 we have what, one is 7, another is 2, right? So what we will do here, actually first of all we have removed Paul from the queue. Now 4 has 2 children, the first we have 7 and another we have 2. Then what we will do, the 7 we will return from here, 7 will return from we will add into the queue. And like this you can see the here, right? We are adding 7 here in the on the queue. Now we will add the 2 will also, so right? So left and right children we have added here, right? So now we will do the you can say poll, right? 7 and 2 will added, 4 we have already gone through. Like this we will, now we have removed 7 and on the 7 we have one kid is there, right? That is 6, right, as you can see here in this part. So 6 is there. Now we will add onto the queue, right. After the you can say swap. Now we will go to the queue, we will add the 6 onto the queue, right. So this part is done, right. Now what we will do, we will remove 2 and then we will add its children 1 and 3, as you can see right here. Now what we will do, we will add onto the queue. So now what we have, finally we have 1, 3 and 6, right, onto the of the same level, onto the queue, right. So these are all the leaf nodes, you can say, and so they will have no children to add to the queue, correct. Let me recap again what I have did till now. So this is our iterative approach. We have left and right children. Then we will first move to the 4, then we will move to the 7 and 2, and then in the last one we will move to 6, 1, 3, right. No, this one, right. So what we will do, we will start from the, we will add 4 into the queue. Next what we will remove the queue. We have 4, we have two things, 2 and 7 as children. We will add, we will we will do the swap and then we will add on to the queue, right. So 7 will come, then will 2 will come, right. So 2 and 7 is look like this. And then what we will happen, we will remove from the queue 7 and we will add we have only one queue, only one children is there, another is nothing but we have null here, right. So what we will do, we'll do swap here. So after the swap it will look like 7 and this one. Now it is in the right side, previously it was in the left side, right. So after the swap what we will do, we will add on to the queue, right. uh, we have pushed into the queue, you can say, you can add on to the queue. Now so what will happen, we will remove 2 from the front. Now front have 2 element 1 and 3, right. So like this one we will do the swap, right, 3 and 1 it will become. Now what we will have, we will add on to the queue. So now what we have, 6, 3, 1 we have onto the queue. There are all the leaf nodes we have on this level, so they will have no children to add to the queue, right. I think understood. Finally what will happen, the time complexity we'll talk about. So we are going with all the nodes, for this one, then this one, this one, then we are going to this, right. So all nodes we are traversing, that's why we have to say O of n is a time complexity. For the space will remain same, O of n. Now let's talk about the complexity, programming. So first what we will do, we will check the root, right. If root is null, right, then we will return null. If this is the tree is null, then we will return null, right, we will not do anything. Now we will take one queue and on the queue we will add the value, right, that we have seen here. We are using queue, right, this queue. So we will take a queue and what we will do, initially we will add onto the add root onto the queue, and then we will start the while loop, right. So this while loop will get called until queue is not empty. So first we will remove the root node from here, queue dot poll. We will remove one element that is called current. So from the current, right, what we will do, we'll do the swap, right. We'll do the swap here. To do the swap, we will take one temp, we will store left one. On the left we will add right, and the right we will put the temp, that is swap, right. Once this is swap, we will check if current not null, and if current not null, we will add on to the queue, right. Current dot left is not this one, means all the subtree value, right. Similarly we will do for the right, if not empty we will order into the queue, and finally we will do the return, right. So this is also very easy approach, right. So as you can see, we have gone through this two approach. So if you like this video, please hit subscribe and comment on this video. Okay, thank you so much guys. If you like this video, please hit subscribe, and for more videos you can say. Thank you so much.